This is the fourth video for the 6-2E lesson. Um, I'm just going to offer some suggestions and maybe some like of the sort of cheat sheet ideas or tricks for simplifying nth roots. First off, in the Desmos lesson, there should be a version of this. This is really helpful in knowing when you're going to get no real root. And so when you have your index, which is n, and it is even, and your radicand is negative, you know that it's no real root or no solution, then you shouldn't bother trying to break this up. If we have a negative, though, with an odd index, then we can actually do the problem. And we usually just ignore the negative, do the problem, and then attach the negative at the end. So in the Desmos slides, you're going to go through all these problems. And I'm just going to kind of point out a couple of things without hopefully doing too many of these. First of all, pay close attention to the index so you know how many sort of three of a kind, four of a kind, five of a kind that you're looking for. So this is like seven of a kind and five of a kind. Um, and make sure you include that in your final answer as you simplify. Um, if there's any leftovers, let's look at maybe 28 as an example. So fourth root, we might just do 12 times 12, 4 times 3. And if you don't need to see this yet again, then by the way, by all means, skip or pause this portion of the video. And we're looking for a four of a kind. So we have, oh, there we go, four twos, out comes one. And then we have fourth root of, and we have 3 and 3, which is 9. Normally, if I've circled these, so maybe I'll highlight them so I don't confuse myself. And then I've actually, now that I've just messed that up, there we go. And I've usually underlined my leftovers. As you do these also, I would quickly just scan through, or you might even scroll through all the slides and find problems that have no real root. So we're looking for an even index and a negative number inside. And so we won't even bother doing something like this, no real root. So the index could be a 2, 4, 6, 8, 10, and we need a negative radicand. And the last thing is with variables that generally have exponents. Um, and this was probably something that you came upon with square roots, is that you are essentially dividing. The trick to this is you just do how many times does 4 go into 12? How many sets of 4 y's are there? And 4 goes into 12 three times, which means that this will simplify to y cubed. If you haven't figured that out, I would suggest maybe trying that now, maybe even expanding it out to prove that. And this works all the time. If you have leftovers, then your leftovers or remainders just get put back inside as the radicand. So 5 goes into 7 one time, so 1a will come out. Our remainder is 2, so a squared's left. And that kind of makes sense because there are 5 a's being multiplied in here, and then 2 left over. And out comes 1 representative, so we don't put a to the 5th here. It is now just a. And 5 goes into 10 2 times, b squared. So it'll be 2 sets of 5 in there and none left over. And so our final answer is a b squared, 5th root of a squared, just kind of cleaning up our final answer. So there's some suggestions. Trying to use this trick with variable exponents, trying to identify any that have no real root. And then for other ones, just breaking it down and looking for the four of a kind in this case that you're looking for and putting everything back together with your index in your final answer.